Sitting in chemistry class, your eyes wander to the most widely used tool in all of chemistry, the periodic table. As you stare down the graphic, you ponder the origins of all 118 elements. You've learned that many of the lighter elements are formed in the cores of massive stars and wonder what extreme conditions might be needed to forge even heavier ones.
To answer this, we must look at the clash of two monsters known as neutron stars. Firstly, what is a neutron star?
A neutron star is the stellar remnant of a star 8 to 20 times the mass of our Sun. At the end of its life, its core collapses in on itself, literally squeezing protons and electrons together to make neutrons. These neutrons are crammed as closely as possible, yielding an incredibly dense object with the mass of more than 1,000,000 Earths, compressed to the size of a city. This is a neutron star.
So, where can we find two of these cosmic curiosities in order to make heavy elements? A binary system, of course. Binary systems consist of two stars in an orbit around each other, and in some cases, these are neutron stars. Over time, their mutual gravitation can lead them to spiral inwards and merge in a violent collision. The outer layers are flung into a whirlpool of neutrons around the merging neutron star interiors, where the combined core has now become a black hole. Gravity no longer keeps these neutrons stable, and the nuclear blob surrounding the black hole breaks up into small clumps of neutrons. Through a process known as beta decay, some of these neutrons in these clumps decompose into protons, leaving behind some semi-stable isotopes in a sea of neutrons. Now this is where the magic happens, where new elements are made. In this hot, dense configuration of neutrons and semi-stable elements comes the rapid neutron capture process. The newly formed isotopes are bombarded with neutrons to form heavier and heavier nuclei. Through beta decay, some of the absorbed neutrons are converted into protons, and since the atomic number relies on the amount of protons in an atom, this creates heavier and heavier elements. Most of the natural elements heavier than technetium are spawned from these neutron star collisions. In fact, about 100 milligrams of your current body mass comes from one neutron star merger. Scientists have traced most of the heavy elements on Earth today to a neutron star collision predating the birth of the Sun. Billions of years ago, some neutrons were ripped out from their parent star, mutated into semi-stable elements, bombarded with neutrons, then escaped the leftover black hole to travel 1,000 light years in the vast, barren cosmos to become part of the intricate collection of trillions of cells that is you. These neutron star collisions deliver a tangible significance to Carl Sagan's immortal quote when he told us, "We are star stuff."